What?
No? Okay. We didn't get that far into IDT. I thought I did. Okay, question. Was I ever 2 feet tall?
Yeah, we did.
See, I did use that example.
Yeah, you did.
How do you know?
Because you're where you are now, you couldn't have.
You're much taller than
I'm much taller now, and I was much smaller once, right?
Yes.
Than 2 feet. That's the idea of intermediate value theorem. Think intermediate. It's not beginning, it's not advanced, it's in between. True? Inter, in between, it's a prefix. Okay, so intermediate, in between, value, function value, y value. If I ask for the value of a function, I'm asking for the y value. So, in between, y value theorem. How does that help? F is continuous, that's the if. On a closed interval, that's also the if. K, who is K? What are f of a and f of b? Are they x values or y values?
Y values.
K is an in-between y value. K is an in-between y value. If f is continuous on a closed interval a to b, then, and if K is within f of a and f of b. Okay, so if I was to go ahead and, on my graph, mark an A, an arbitrary A, and an arbitrary B. I'm just making it up. I mean, I put the little dashes, but you know what I mean. There's an A, there's a B. Okay? And if this is f of a, it's a y value, right? And this is f of b, it's a y value. And if you know that f is indeed continuous, then for any k, and it could be a specific k, it could be a general k, but for any k in between any of those y values, there has to be a c. So let's just choose a k arbitrarily. We'll choose it this one. Okay? There has to be a c somewhere, and you don't even know exactly where. There has to be a c somewhere where this function is going to go through that point. That's what the theorem says. If I know f is continuous, to get from this y value to this y value, whether it's a line or a parabola or an exponential function, whatever it is, to get from here to here, and if it's continuous, it's going to have to cross through this y value, this in-between y value, for some x in between a to b. If you guys understand the theorem, you shouldn't get it wrong in the wording. F is continuous. K is my in-between y value, in between f of a and f of b. And if all of that is true, then there exists at least one number c, one x value c, in between a to b, such that f of c equals k. So I'm going to go ahead and say f of c equals k. Now, do I know exactly when that happens? No. Where that happens? No. How many times that happens?
No.
No. Couldn't it be something funky like this? And it goes through k a couple times? It doesn't have to just go through k once. It could go through k a couple times. It could be some sort of funky function. But the point is, there has to be some place to get from here to here such that it crosses through k. What if it was a straight line? Would it cross through k somewhere?
Yeah.
Mm-hmm. What if it was a parabola? Would it cross through k somewhere?
Yeah.
Because remember, k is just a horizontal line. The point is, to get from here to here, it has to cross through. So that's the same way that I can ask, was I ever 2 feet tall? Yes. Was I ever 4'2"? Yes. Was I ever 5'10"? Yes. Was I ever 5'1"? Yes. Am I now? No, but that's the whole point. That's how you know I was all the others.
What is the K?
Oh, the little e for both of these means is an element of the set or of the interval. So k is any value in between f of a and f of b. Could be a specific number if they give it to you. If they say 6, you might have to find f of a and find f of b and say, is 6 guaranteed? If it's in between, it's guaranteed. If it's not in between, then no, it's not guaranteed. If it is in between, it's guaranteed, and they might ask you, hey, set f of x equal to k and find the c in between that the theorem proves exists. Now, let's see an example. There we go. That's it. Yeah, it did. Yeah, it did. There is another application to approximating roots. We are going to see an example in just a second. Just hang in there. My computer is dying. There it is. Just kidding, it's not dying. There is another application for IVT. And don't worry, this isn't a forever card. It's just something for you to understand. We can use IVT to approximate roots. This technically is not the programming that your graphing calculator uses, but it could be. just a bit more complicated and, what's the word for it, a bit less efficient, because it would take more programming and more thinking, loosely speaking, on the calculated part. But we can approximate roots using IDT. And here's how we can do it. If f is continuous, and if f of a and f of b, if we're able to choose an a and choose a b, such that f of a has one sign, like positive, and f of b has another sign, like negative, if we can find two different x values, a to b, where their respective y values are non-zero and have opposite signs, then there exists at least one solution for C. You guys know what I'm going to write? Yeah, within the little e, within a to b, such that f of c equals 0. Does that make sense from IVT?
Because it has to cross.
It has to cross the axis to get from the positive to the negative. What if it was negative to positive? It would have to cross the axis. Do I know how many zeros? No. But I know at least one. I know at least one. And how does that help? Well, you guys remember those really nasty, what was it called, the rational root theorem? Where if you have a gross polynomial, just put it off to the side. You have a gross polynomial, and let's say that gross polynomial was something like f of x is equal to 4x to the 4th minus x cubed plus 10x squared plus 1. Let's just do plus for, we'll keep it that way. No, put plus. That's more fun. Question. How can you guys help me find the zeros of that function?
You could not. Well, could we like group? We could do grouping.
We do it 4 and 1. What I'm saying up here is that we could think of the different possible rational roots would be 1 over 1, 1 over 2, 1 over 4. I think that would be all of them. We take all the different factors of that one, all the different factors of that one. These are all the different possible rational roots, like easy roots. Could we plug in 1? If we plug in 1, that's a positive, right? If we plug in 1/2, guess what? It's going to be positive. If we plug in 1/4, guess what? It's going to be a positive. Hold on, guys, look at this. If we plug in a negative 1, what would that be?
It's
Also positive. If we plug in a negative 1/2,
It's always,
still going to be.
is it always positive?
still going to be positive. How about negative 1/4?
Again, right?
Yeah. Does that mean this can never be negative? Why am I looking for negatives? What's the big deal? If it's always positive, what's never going to occur?
It's never going to
It's
cross.
not
It's never going to
I
cross.
need to find a sign change to guarantee there even is a 0. Now, what if I was to give you a different function? I made it all positive on purpose. An x cubed, that it could be a negative, and so it could go ahead and outweigh. There might be like a little decimal or something. It wasn't one of the nice ones. What if I was to give something like 5x cubed minus 7x plus 2? Okay, let's not even worry about the possible rational roots, but we could. We could do 1 over 5, 2 over 5, 1 over 1, 2 over 1. Can anybody find a value, if you plug it in, that would make that positive? How about 0? It's okay.
No.
Plug in 0 and you have a positive 2, right? Okay, so at x equals 0, I know that f of 0 is positive. Okay, find one that's negative.
1. Right. Oh, wait, no, that would just be 0.
1 is 0. Oh, well, we just found one, didn't we?
Oops.
That's okay, try 2. 2 cubed is 8, 40, 14, ooh, that's positive also.
Yeah.
Can we go backwards?
Go backwards.
No, wait.
We could do 1.5,
How backwards would make that positive?
3 halves.
No, it could be.
No, we trying
You
to
can go negative.
Yeah, if you get a big enough negative number, it should.
A big F negative number?
Negative.
Because if we keep the negative on the x cubed,
Negative 2. So negative 2, that'd be negative, yeah, that would work.
yeah.
Okay, so x equals negative 2. F of negative 2 is less than 0. Okay, now we already figured out x equals 1 is a 0, so let's not go to the positive side. But is there only one 0 to this function, yes or no?
No.
No, because we already figured out at 1 is a 0, but what else are we guaranteed somewhere in between 0 and negative 2?
Another one.
Another one.
Another one, right? Another one. So, if there was something where you had a nasty function and where you had like possible zeros, you didn't know how to factor, you didn't know how to long divide, could you at least figure out a range for where a 0 has to be?
Yeah.
And we can actually keep narrowing. We could try, hey, what about negative a half and negative 3 halves? Hey, what about negative 3/4 and negative 5/4? We can narrow, 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 just by plugging and chugging and know approximately what a 0 is. Anyway, interesting application. That's not exactly how calculus tests this application of IDT. They test it in different ways. But long story, once again, if I have a continuous function and if the two endpoints, the y values of the two endpoints have opposite signs, there has to be a 0 somewhere in between. So let's go and check out how homework tests. Some of you guys kept going and got to this section. Some of you guys didn't. Can we talk really quickly about the book, though?
Sure.
I think this is the first actual copy of a problem from the book that I've made. Has anybody wondered what the QR code is for? Or why some of the numbers are highlighted in red?
I wondered, but I just don't.
I sent you to a video on the website of a teacher teaching how to solve the problem.
Oh, wow.
Which problem? The
The
big
red
ones.
ones?
Oh, that's
The red ones.
nice.
Pretty sweet.
Now, if you read the book, maybe you would have found that out earlier, but that's okay, I'm just letting you know now. These are the beginning of every section. Anyway, you can scan the QR code, and I think there's actually a CalcChat app, and you can open the app, you can scan the QR code, or you can just do it with some QR code reader. It will send you to the website where the teacher is teaching this problem and how to solve it. Now, once again, are they neat?
No.
No, so could they do things a little differently?
Yeah, I didn't like it.
And yeah, some of them, I forget which one Katrina likes, and Bridget. They liked one of them, they didn't like another one, and some, I think the ladies.
Some of them are incompetent and shouldn't teach.
No, not incompetent. They just, some explain it better than others, and some are more interesting than others. But is that kind of cool that all the pink and red ones have a teacher teaching you how to solve it? It's better than CalcChat. Anyway. So sometimes I give you pink red ones just to be like, hey, if you don't know how to do it, go check it out. Because the whole video is there.
Is that
Yeah. Question, what do you guys have for homework, 99 or 100? Okay, let's do 100. Anytime I have a video, you have to hear me do it, let's do 100. Verify that IDT applies to the indicated interval and find the value of C guaranteed. So I'm trying to do two things, verify IDT works and then find the value of C, that's guaranteed. So, long story short, question, do I have an A and do I have a B?
Yes.
Yeah.
Yes, I have 0, I have 3.
Close.
Do they give me a K?
Yes.
They give me a special Y value, 0. They want me to see, is this Y value guaranteed to happen in between here and here? Well, I don't know. The in-between Y value, I have to figure out if it's in between the Y values of my A and B. How do I find the Y values of my A and B?
Plug it in.
Yeah, let's find what's going on at 0, and let's find what's going on at 3. Plugging in 0, we get? Double check my mental math, but I think it's 8. Plugging in 3, we get 9 minus 18 plus 8. That's 0? No. 10.
No.
Sorry. I don't know what I was doing with
Negative
9 minus
9 plus
18.
eight.
Oh, negative
9 plus 1. There we go.
That's a struggle,
Find the value.
So that proves I have.
right? 9 minus 18 is
It's
negative
basically
9
one
plus
day.
8 is negative 1.
Okay.
Okay, so.
So can I say that IDT applies?
Yes.
Yeah.
Since K is within the.
Pause, F is continuous.
Okay.
Does that make sense? Start there. If
Yes.
F is not continuous, I am in all sort of trouble. Because it can jump, it can break, it can do all sorts of funky things. So, it's a polynomial, yeah, F is continuous, and now say what you were about to say.
And wouldn't K exist in the interval?
Mhm.
Or
few different ways of writing it. You can do it that way, that's kind of like within our notation. K equals 0 is within. Another way of writing it, don't worry, this is just for me illustrating. You could also say f of 0, which equals 8, is greater than k, which equals 0, is greater than f of 3, which is negative 1. You can state this, and you can say because 0 is in between 8 and negative 1, you can put it that way as well. You can use inequalities. You can separate the notation of the f of 0 and the f of 3. So the other way, if you want to see it, I was just showing you different variations. You can say it that way. So you're showing the 0 is in between the negative 1 and the 8. So anyway, there are many different ways of saying it. Long story short, I just have to say that yes, this special k value is in between f of 0 and f of 3. And how do I solve for c?
C is equal to
Set your f of x equal to 0. Now, technically it's f of c, so I'm not going to say this is wrong if you just take your entire function and set it equal to 0. You're going to solve for x, and then at the end of the day you can say x equals c, which equals whatever you find.
Wait, so.
Or,
Can we just test?
couldn't you just plug in c squared? F of c, if it helps you, just make your x value c,
So,
because we're just solving for when this is true.
so for 99, instead of plugging in 0, you plug in 11?
Set it equal to 11, but yes. Plug in 11 for the y value.
Okay.
So you can make them just x's, no big deal. X is c, c is x. Or you can just make them c's if you want. I'm setting this function equal to who they said he must equal. Now, hopefully you guys see that I'm just going to be using factoring, right? So I'm going to have c, c, I'm going to have 4, I'm going to have 2, minus, minus. Solving that's going to get me c equals 2 and 4. Now pause. Are both of these guaranteed by IVT?
No, just the 2.
Just the 2 because is 4 one of the guaranteed IVT values if it says there exists a c within A to B? The only one that is within 0 to 3 is 2. So I would say c equals 2 is the value guaranteed by IVT. And I'm just putting that so that you guys understand why he's the only one I'm allowed to use.
If they're both in between 0.
Then I would use them both, yeah. I would use them both. Alright, IVT is a little bit weird, but once again, IVT says if the function is continuous, and if you're curious about a y value, as long as that y value exists in between the y values of the endpoints, IVT says, yes, the function is going to have to hit this y value at some point, and how do we find when that occurs? We just say, oh, take the function, set it equal to the value that it's supposed to hit or it's supposed to cross, and find the x value that fits in between A and B. So we're checking, is f continuous, number 1? Is the special y value within f of a to f of b? Number 2, and then we're saying set the function equal to the special y value and find the x, which is really just c. But be careful, only choose the one that's within, or the ones that are within the interval. Okay? You have an example, number 99, also has a video online that will walk you through maybe a little bit different way. That's the end of section 1.4. We're doing workspace tomorrow, but for right now, let's play just a little bit more with infinite forms. The nice thing is, when we talked about discontinuities, I was like, in the summer packet, you should know poles versus vertical asymptotes. So I went ahead and covered most of this already. But there is a section, and there are great homework problems, and there might be just a little bit more depth. The nice thing is, kiddos, I know we only have 14 minutes, but we only have 1, 2, 3 pages.
Oh, well.
Okay? So it's short. I'm gonna give you a second to write down what you need. Get the example. And I'm checking Mr. Strike's email.
Hey Steve,
Yeah,
were you gonna make a horizontal asymptote card or code?
that's what I'm thinking of doing for degree test. That'll be tomorrow's notes though, Sally. There it is. They need to miss second period from 8:45 to 9 o'clock. Huh. Interesting. Mr. Strike didn't technically say to get out early from first period, but you need to, David. So let's say at, in like 5 minutes you go.
5 minutes?
Yeah. Try to keep an eye on it, like 38.
Oh.
He said just 45, but they're trying to serve right now, so. I'm not sure what messed up. If we're talking about limits, seeing this will tell us plus or minus infinity, check the sign, right? Plus or minus infinity, check the sign. Infinite form. But it also tells us vertical asymptotes. So if you're given a question that's a little different than a limit problem, the example you're writing down doesn't say limit, but doesn't it mean the same thing?
Pretty much.
Analyze the behavior, analyze what's going on as the function comes toward, approaches the function. It doesn't say, towards the vertical asymptote. As the function comes towards the vertical asymptote, analyze the behavior. Don't we just need to figure out the limit? Okay, so don't stress so much about all the extra wording. Just think about how would I do the limit. Now we're going to do it two different ways. Graphically, we'll come back to that in just 1 second. Let's think algebraically. We're going to come from below the vertical asymptote. We're going to come from above the vertical asymptote. Now guys, I've done the writing out of 1.9 and 2.1 before, right? So let me not have to write it out this time, is that okay?
Yes.
Let's just do it. If I'm coming towards 2 from below, 1.9 sounds good, right? Okay. So what would 1.9 minus 2, what sign would that be? And 3 is just going to stay a positive. So I'm going to have a positive over a negative, so what's this going to lead me to? Negative infinity as I come from below. So as I come from below, I might not know everything that's going on, or maybe I should. But I do know the graph is going down. Does that make sense? If I come from below 2, the graph is going to negative infinity because plugging in 1.9 is a negative and a positive. A positive over a negative is a negative. What would be a good number to test for above 2?
2.1.
So 3 is a positive no matter what. 2.1 minus 2 is a,
Positive.
and a positive over a positive is a. So what's going on as I come towards 2 from above? Pause. Why should you have been able to figure that out anyway? What basic graph do you know that corresponds to this? Now, the minus 2 shifts it 2 to the right. But couldn't you figure out the vertical asymptote is at 2 just by looking at the denominator?
Yeah.
So you can think it's 1 over x-ish, but shifted to a 2. Oh, that makes sense. There's no negative to flip it. So maybe if you know transformations of graphs, maybe you could have gotten there a little bit faster. But either way, did it work plugging in 1.9 and 2.1? Yeah. So what would the behavior be? Well, as I come from below the vertical asymptote, my graph is decreasing without bound, and as I come from above, it's increasing without bound. But I don't mind if you just use, f of x is going to negative infinity from below, and positive infinity from above. Yeah. So the question's just a little bit different, but basically, can you use the limits to answer? Totally. I don't mind that. How do we determine behavior in a vertical asymptote without a graph? Well, we just did. We just did. So what do you guys see as far as what comes next?
Table.
Table. Is that where we started with limits?
Yeah.
Yes. What I want you to basically see, a different way of wording positive and negative infinity. That's all. Let's not even stress about a table, unless you want to remind yourselves really quickly of what's going on. if we're coming from below 2, if we're coming from above 2, just a quick reminder, it's not bad. We could plug in 2.1, 2.01, 2.001. We could plug in 1.9, 1.99, 1.999. Just to remind you what's below and what's above. But this is just going to keep on getting bigger and bigger and bigger and bigger to positive infinity. And this is going to just be getting smaller. Sorry, I did it the totally opposite way, towards negative infinity. The other one's going to positive infinity. But wait, if you did ever get stuck and if you did ever need to use your calculator, would your calculator spit out an actual little infinity symbol to say no? What would it do when you plugged in closer and closer?
It would just get to a really big number and then eventually.
Really big
say
negative? Oh, wait, but
overflow
really big in the
error.
calculator, isn't it going to have like an E
Well,
and
yeah,
powers?
scientific.
It's going to be scientific notation. So it's going to be negative with an E and positive, good to go, yeah. And positive with
I'm
an
gonna
E.
wait till 40.
You sure?
I'm gonna just wait.
That's true, they both have missed it. Yeah.
On the AP exam, do they ever ask you to solve something like a specific way, or do they always just want the answer?
It's a good question. In general, the types of problems we have done so far are almost all multiple choice type questions, which means they're not checking your work. They're just checking, could you get the answer? Like a Scantron, like an SAT, without the fill-in. But there are questions called FRQs where they not only give points for you getting the final answer, but for you getting all the steps in between. So in that way, there are definitely proper ways of solving where you need to make sure that you are showing your work and you are exhibiting full understanding of the process and the answer and its application. So what we're learning right now is the foundation for that.
So, but they wouldn't ask like do it numerically or something? You just do it the way they.
But there might be a function that's tricky that you get stuck on algebraically, you can use your calculator. Sweet, at least you have a table to double check.
Yeah.
Does that make sense? Tyler?
Yeah, but they don't actually care what your work is as long as it's valid, right? Like if you do it
On the
in extremely-
FRQ?
I mean, they might be mad at you, but if you
Well,
do it in
the
extremely-
dilemma
no,
is
it's
if
okay.
they ask you to solve a certain way, and if in your head you're going to get to the right answer, but you showed something that's technically incorrect in your process, that's a good example. For instance, if this is super silly and this is not ever going to be an FRQ, but if you actually put underneath 2.001 infinity, that's technically wrong. That's not true. So if you were to put a wrong statement, even though you get the final conclusion right, once again, they would never ask for work on this. But if you put something wrong in the midst of your way to a right answer, they would have to take off points if they see anything incorrect. And that's not just in math, that's also in your reasoning, in your explanations, in your units. So there is a very high importance put on not just getting the answer right, but getting the process right as well. But yes, there are multiple different ways in some of them to get to an answer. Don't worry, it's no school app, it's still at like 4 minutes, 5 minutes. Last page. So how do we determine the behavior near the vertical asymptote without a graph or a table? Pretend plugging in something just a little bit below and something just a little bit above and checking the sign. Okay, those long story short, is this section no? No. The nice thing is I had you practice this multiple times in your notes, but homework didn't have you practice it a lot. And I need you to get down the difference between 0 over 0, which is, keep going, and a whole. No, you're right, a whole, removable discontinuity. Looking for a constant, and a number over 0. Vertical asymptote, looking for a sign of infinity and comparing. Okay? So, you might see the questions a little bit different in this section, but you might also be given limits as well. So if you're going the limit as x approaches a of a function, if you have a number over infinity, let's review real quick, plus or minus infinity and check the sign. And can we do that without the calculator? And so you're going to practice that in section 1.5. I'm going to go ahead and pull up 1.5 homework. You guys can keep writing. I'm just getting it ready so I can show you. As Nathan asked this question, go ahead, bud. What's up?
How can you tell if there's a hole by just looking at the graph? Can you?
By looking at the graph?
Or not, my bad, not looking at the graph, just, the function, yeah.
Denominator. Do you mean a whole or do you mean a vertical asymptote?
Whole.
Denominator, find the zeros and plug in. If it's 0 over 0, it's probably a whole. The only time it wouldn't be a whole is if it's something like a piecewise function and they've messed it up for you. Do you know what I mean? They've filled it some other way. If you guys want, open up your spirals. Let's write down section 1.5 homework. And let's see how intense it is. Tomorrow is 1.6, 1.5, 1.6. The nice thing is we've gotten through most of the crazy concepts. 1.6 is a little bit more new. It's horizontal asymptotes degree test, which we did practice some in homework, or sorry, in the summer packet. If you guys notice, at least from the last two homeworks, 1.5 is shorter, yeah? Like 5, 6 problems shorter, not tons.
Well, the 1 through 8, but that might be easy stuff.
This should be good. It's not as short as like the first homework, or the section 2 homework, but it's definitely shorter. But here's the sticky part. 1.5 is due tomorrow.
Ah, shoot.
Now, hopefully you were working on 1.4 because you guys were able to do all of it but the last couple. We're going to grade 1.4 and 1.5 tomorrow. Alright, so have them ready. I'm just going to warn you, I'm doing a spot check and why. Because there's a test coming. I need you guys to be caught up on homework. You can't be catching up on homework the night before the test. That does not give you understanding. Oh, question?
Did they know you?
Yeah. I sent it out at 40 because I figured you guys need to be out there early.
Everything?
Do you guys want a quick homework question real quick? From homework section 4? You're trying to do the limit. As x comes towards 3 from above of ln of x minus 3.
I think it's the graph. I was like, it doesn't
It's
go.
an ln graph that's been shifted. Where is the vertical asymptote now?
It's at 3.
At 3. Think about the basic graph. It's an ln.
Wait, so when they were asking from the right, they just,
I mean, from above.
So you're playing
Think about the graph. I would. Because it's harder to think about ln values. You're like, I don't know. But if you think about the graph, this is why I have the third part of the graph.
I did it wrong.
Because you can say vertical asymptote or negative.
We're at 18.
Oh, piecewise function. Plug in one to the top, plug in one to the bottom. If it agrees, then this is all this one should be made, this one should be checked. Like discuss the continuity, and since 1 equals 1, continuous. I would say continuous already. Give me 1 second, Tyler.
Is the spirals and the notes are due on testing, right? Just like,
I'm just going to spot check tomorrow because I really need you guys to have 1.4, 1.5 fully attempted. You might have questions. Good.
hi, Sonny. Well, I'm talking to you.
Well, if you're coming towards the
I said
below,
hi.
it'd be DNE. Oh, I see.
Hey,
For
Sarah.
the test, it'll be negative
You
3.
just think I'm serious.
Guys, real quick, on letting us know that CalcChat said DNE. Why did CalcChat say DNE?
Because technically, yes.
But what should we answer getting ready for the test? And for
Negative for the test. Is that going to be an
I
EP
get it, be
test?
out of your chapel.
Or do the EP test people just say
Negative
DNE?
3.
Oh, okay.
They'll only say DNE if it does not agree. Oh, no, second, I get that. Sorry, I was saying chapel based. Thank you, Ms. B. Bye, everybody.
Good morning. If you're wondering why I get here so early, it's because I come straight from PE, so.
Oh, that makes sense. It's
Yeah.
already all changed back and straight.
Yeah.
Oops, I need to turn off the recording. We need to still finish. Okay.